Good morning. This recording is for Chapter 10, Lesson 2, the Pythagorean Theorem. In a right triangle, the side opposite the right triangle is the hypotenuse. That is the hypotenuse. It is opposite the right angle. The hypotenuse is also the longest side of a triangle. It is always the longest side of any triangle, especially right triangles, because you don't necessarily have a hypotenuse without a right angle. So whenever you have a right angle, you also have a hypotenuse. The other sides are called legs, and they form the right angle. So if that's a leg, you get a right angle. All right? All right, Pythagorean's theorem describes the relationship between the two leg lengths and the hypotenuse length. And we can write that as a squared plus b squared equals c squared, which also looks like this. It's very easy, and it's very easy to memorize, so please memorize it. Where a and b are leg lengths, and c is the length of the hypotenuse. So, we can use this same formula to figure out hypotenuse lengths if we know the two lengths of the legs of the right triangle. So if we say that one of the lengths is 7 centimeters and the other length of the leg is 24 centimeters, then we can do 7 centimeters equals A, 24 centimeters equals B, and we don't know the length of C, which is C squared. So let's plug in for A and B. 7 squared plus 24 squared equals c squared. 7 squared is 49, 24 squared is 576, and c squared is just c squared. But we need to figure out what c squared is, so we're going to add up those, and we're going to get 225 equals c squared, square root it, and we're going to get c equals plus or minus 25. But again, because this is a length, c is a length, it cannot be negative, so it's going to be positive. So the hypotenuse is going to be 25 centimeters long if the legs are 7 centimeters and 24 centimeters. All right, we can also determine a leg length if one's missing if we know the hypotenuse and the other leg. So if one of the legs is 4 miles and the hypotenuse is 8 miles, we can figure out what the other length of the right triangle is. So what is B? So we know that A squared plus B squared equals C squared, where A is 4 and C is 8. We know that 4 squared is 16 plus b squared equals 64, because 8 squared is 64. We're going to subtract 16 on both sides, and we're going to get b squared is equal to 48. Square root both, and we're going to get b is plus or minus 6.9. But again, since we're dealing with lengths, and lengths cannot be negative, we're dealing with the positive version of 6.9. And also 6.9 was rounded, so b is approximately 6.9 miles. So again, we were rounding to find the length of B because it was actually quite more decimals after the 0.9, but it was approximately 6.9 miles. Okay, conditional statements. Now, I don't expect you to quite memorize what a conditional statement is right now, but the moment you hit geometry, which is in about a chapter and a half, you're going to have to know what a conditional statement is. So let's talk about conditional statements. An if-then or if-then statement is called a conditional statement and has two parts. The if part is the hypothesis, the then part is the conclusion. The converse of a conditional statement switches the thesis, hypothesis, and the conclusion, and sometimes the converse of a conditional is not always true. And an example of this is, if there is smoke, then there is fire. The converse would be, if there is fire, then there is smoke. You guessed it. Now, again, some converses of conditional statements are not always true. The only thing is when we're dealing with the Pythagorean theorem, the converse is actually true, and it's always going to be true. So let's go ahead and talk about the converse of Pythagorean's theorem. So we can determine if a triangle is right by using the converse of the theorem. So the converse of the Pythagorean theorem is, if a triangle has sides A, B, and C, and a squared plus b squared equals c squared, then the triangle is a right triangle with a hypotenuse length of c. So basically, it's just the opposite of what the Pythagorean theorem is, and it always holds true. All right? So again, we can figure out if we have a right triangle by looking at the lengths of A, B, and C, and then determining if the Pythagorean theorem holds true. All right? So there we go. So a right triangle has, a triangle has it. We don't know if it's a right triangle yet because we haven't done the math. A triangle has a length of 10 meters, 24 meters, and 26 meters. Is the triangle a right triangle? And just remember, the longer length is always the hypotenuse, and the converse of the Pythagorean theorem is always true. So if we can plug these three numbers into the Pythagorean theorem and we get a true statement, it means that it's a right triangle. If we were to plug them in and get a false statement, it means that this triangle is not a right triangle. So let's go ahead and plug them in, and again, the longest length is always the hypotenuse, so you always know what C is, and it doesn't matter what A and B is because it's just one of the other two numbers that are left, right? And since we're adding, it doesn't matter which order they go in because of the commutative property, not commutative property, excuse me, commutative property of addition. Dumbest DH, I'm having a brain fart today. All right, that's probably because I have an audience. Everybody say hi. Hi. That's my audience. All right, thank you guys. Back to work. All right, so 10 squared is 100, 24 squared is 576, and 26 squared is 676. So if I add the stuff on the left together, I'm going to get a true statement, which means that the measurements from the triangle provided, right there, is a right triangle. All right, last slide. All right, application. This is basically how we can use the same concept to figure out physics, which is the only reason I passed physics. The only reason I passed physics is because I knew geometry. There you go. So application. If two forces pull at right angles to each other, the resultant force is represented as the diagonal of a rectangle, like below. Down here, the diagonal forms a right triangle with two of the perpendicular sides of the rectangle. For a 30-pound force and a 40-pound force, a resultant force of 50 pounds is created. Are the forces pulling at a right angle? So basically, I just take my A and B force and see if their square roots equal the square root of my resultant force. So we've got 30 squared plus 40 squared equals 50 squared. And we need to see if they give us a true statement. Just like in the last thing, if they give me a true statement, then it is pulling at a right angle. It's right angle, right triangle. See how they're similar? All right, moving on. So we have 900 plus 1,400 equals 225. Guess what? It equals. So that means that it's a true statement. Therefore, yes, the 30-pound force and the 40-pound force are pulling at right angles to each other, and therefore we're happy. All right, I'm done, and you guys should be happy too because it was a video that was less than 8 minutes. Done.